Hello everybody, Bruce here with a series of videos on Module 8. Now this video is going to supplement the other videos on while loops and such that are in Module 8 right now. So what I'm working from here are the slides provided by the textbook author, and I thought I'd just go through them to help you out here. And I'll be probably switching into VS Code here and there just to help reinforce a particular topic. In fact, let me just make this window a little bigger here. Okay, I didn't want to take up the whole screen because it's a pain in the neck to go back and forth between VS Code and a full screen thing. So the objectives of Module 8 are to understand the concepts of definite and indefinite loops as they are realized in the Python for and while statements. Now, we've done a lot with the for statement. You've done a lot, right? We've done for I in range, we've done stuff with lists, we've done stuff with files, but the for statement is a definite loop. It does things a definite amount of times. And we're going to be talking about the while statement in this chapter, and we'll be learning more about that shortly. I also want you to understand the programming patterns interactive loop and Sentinel Loop and their implementations using while statements in Python. I also want you to understand the programming pattern end of file loop and ways of implementing such loops in Python. And again, this is going to be broken into several videos. I'm going to chunk this one up so it's not one big long video. And to be able to design and implement solutions to problems involving loop patterns, including nested loop structures. And there's been, I think it was module 5 or 6, where I had a video on how to do nested for loops. I don't know if you remember that one. And then understand the basic ideas of Boolean algebra and be able to analyze and write Boolean expressions involving Boolean operators. Okay, so let's go back to for loops. Quick review. The for statement allows us to iterate through a sequence of values. And you remember this, right? For and var is just the loop iterator, right? In some sequence, whether it be a range or a list. And then you have the colon and then the body of the loop, right? All that indented code, the things you'll do over and over again within the for loop. The loop index, as I called it before, or the iterator, var, right, in the second bullet there, takes on each successive value in the sequence, and the statements in the body of the loop are executed once for each value, all right? Think this is a review. It is a review. Suppose we want to write a program that can compute the average of a series of numbers entered by a person, right? To make the program general, it should work with any size set of numbers, right? Not just like 10 or 12 or 2, right? We don't need to keep track of each number entered. We only need to know the running sum and how many numbers have been added, okay? So again, for loops. We've run into some of these things before, exclamation point. A series of numbers could be handled by some sort of loop. If there are n numbers, the loop should execute n times, right? If we want to add 5 numbers together, right? The loop is going to go around 5 times, asking for numbers, accumulate the sum, and do whatever we need to do, right? So we needed a running sum, and by now you've heard me say the accumulator pattern is super important, right? So we would use an accumulator, right? So again, here's just some sample pseudocode. So we're going to input the count of the numbers, n. That's what we're going to do. We're going to get that from the user. Again, this is pseudocode. This is not Python code. We are going to initialize the sum, which is going to keep track of the sum, to 0, right? Because we're adding numbers together. We're going to loop that many times We're going to have the person input a number, store it in a variable called x, and then we're going to accumulate x to the running sum, okay? And then after that, we're outside the loop, we're going to output the average, which is going to be the sum of all those numbers divided by n, which is the number, right? This has nothing to do with lists or anything like that. It's just, basic accumulator stuff. And go back in the instructional video library and look. I think it's in module 3, where you'll see a whole bunch of videos on the accumulator pattern. Again, super important. So this is like the code. This is what the Python code would look like, right? We define a main function. We get an integer because we need to know how many numbers the person is going to enter. We establish the variable sum to 0 because it's going to accumulate the sum. We then execute the counted loop for I in range of n, right? Because we need to loop that many times. We are then going to get a floating point input from the user, store it in the variable x, and then we're going to accumulate the sum, adding that new value entered by the person. And again, all those two statements right there are in the loop. We're going to keep doing them for the number of times the user wanted to give us, numbers. And then at the end, we're going to print out the average, right? So again, that's a very basic definite for loop, right? And there's just some examples right there of user input. So those are definite loops. Indefinite loops. So the last program got the job done, right? But you need to know ahead of time how many numbers you'll be dealing with, right? Remember we asked over here, we said, how many numbers do you have? And the human said 5, right? What we need is a way for the computer to take care of counting how many numbers there are, right? The for loop is a definite loop, meaning that the number of iterations is determined when the loop starts, right? Again, you saw the human enter 5, right? Indefinite loops, right? We can't use a definite loop unless we know the number of iterations ahead of time, right? That's why we asked that human, and I keep repeating myself, right? I'm like a for loop, right? We can't know how many iterations we need until all the numbers have been entered, right? We need another tool! Exclamation point said with emphasis, right? The indefinite or conditional loop keeps iterating until certain conditions are met. Okay, so what's that mean? So imagine here, again, this is just death by PowerPoint here. While some condition is true, do the stuff in the body of the loop. Okay, so some new keywords here, some new statements, right? While some condition, which we're going to learn about, is true, do some stuff, the body of the loop. So condition is what we call a Boolean expression, just like an if statement, right? The body is a sequence of one or more Python statements. So semantically, the body of the loop executes repeatedly as long as the loop condition remains true. When the condition is false, the loop terminates. All right, so what's all this kind of mean, right? So look at that little flow chart on the right there, right? So we're going to test the condition. That's what that diamond is for. And the condition, right, is just an example right here. So if the condition is true, we're going to go down here to the body of the loop and do this stuff over and over again. But as soon as this condition becomes false, we're going to bypass the body of the loop and carry on with our code. So the bullet here says the condition is tested at the top of the loop. This is known as a pre-test loop. If the condition is initially false, the loop body will not execute at all, okay? Not even once. All right. So here's an example of a while loop that counts from 0 to 10, okay? A while loop, an indefinite loop. I equals 0. I'm just setting I equal to 0 because we're in charge of keeping track of how many times this indefinite loop is going to do its thing. Check it out. So while I is less than or equal to 10, So I is 0. Is I less than or equal to 10? Bing, 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 true. Print I, okay, 0, and then add 0 plus 1 and assign it back to I. So I is now 1. Go back to the loop. Is 1 less than or equal to 10? Bing, 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 true. Print 1, right? So 1 plus 1 is 2. I is now 2. While 2 is less than or equal to 10, bing, bing, bing. I was waiting to hear you all do it, right? Print out 2. 2 plus 1 is 3. I is now 3. Is 3 less than or equal to 10? All right, I heard you say it that time. And it keeps doing that until this condition becomes false. And then the loop is done, okay? So the code has the same output as this for loop for I in range of 11, right? It's this, these two loops do the same exact thing, all right? Now, they may not be the best examples of, well, they're perfectly, you need to see the similarities between these loops and the fact that they do the same thing. You'll notice that with the while loop, we are in charge of writing our own statement to increment the iterator I, but our friend, the for loop, is doing it for us, right? All right. So the while loop requires us to manage the loop variable I, which I just said in the previous slide, but I like to repeat myself, right? By initializing it to 0 before the loop and incrementing it at the bottom of the loop body. In the for loop, it's handled automatically, right, for us, right? That's because it just does, right? So the while statement is simple, but yet powerful and dangerous. They are a common source of program errors, okay? So check it out. I equals 0. Let's pretend we have a little code here, which we do. While I is less than 10, print I. Does anyone see what's going to happen here? All right, I'll give you a second to think about it while I take a sip of my latte. It's a little late when I'm recording this video, and I need some pick-me-up. So, did you figure it out? All right. Oh, you say you know? So what is it? Yeah, that's right. It's going to go on forever. It's going to be an infinite loop because we never change I. And it's just going to be over and over again. You're going to bust your computer. VS Code, Visual Studio Code is going to just, I don't know, it's going to go into, I don't know. It's just not going to be happy, all right? So when Python gets into this loop, I is equal to 0, which is less than 10. So the body of the loop is executed, printing 0. Now control returns to the condition, and since I is still 0, the loop repeats. This is an example of an infinite loop, okay? I kind of do this accidentally a lot, and you probably will too, all right? What should you do if you are caught in an infinite loop? Number 1, take a sip of coffee or tea or Gatorade or, I don't know, whatever you water, I don't know. First, try pressing Control-C on your keyboard, right? Or Command-C on a Mac, try that. If that doesn't work, try Control-Alternate-Delete. If that doesn't work, push the reset button or pull the power cord, okay? Because sometimes, especially on older stuff, right, it just, there was no way to break it, all right? Interactive loops. One good use of the indefinite loop, indefinite, right, the while loop, is to write interactive loops. Interactive loops allow a user, a human, to repeat certain portions of a program on demand. What's that mean? Remember how we said we needed a way for the computer to keep track of how many numbers had been entered? Let's use another accumulator called count, okay? Count, right? So check it out. At each iteration of the loop, we're going to ask the user if there is more data to process. We need to preset it to yes to go through the loop the first time. So again, this is pseudocode, right? So I'm going to set a variable called more data to the string yes. And then I'm going to say, hey, while loop, while more data is yes, right? Again, pseudocode, don't knock me for no equal signs or anything right yet, all right? I hear you, you're wanting to, right? While more data is yes, get the next data item from the user, process that that item, however you may do that in your code, and then at the bottom of the loop, ask the user if there's more data. If they type in yes, we're going to loop the loop again. If not, we're going to blow out of the loop and we are done. Okay. So some more on interactive loops. Combining the interactive loop pattern with accumulators for sum and count. So check this out. This is actually, you know something? I'm just going to show you the Python code because I just want to show you that. So again, I'm setting an accumulator called sum and I'm setting it to 0. And I'm setting count, right? Because count is going to count how many times we've looped in this situation. I have a string called, a variable called more data that's set to the string, lowercase yes. And then I have a while loop, an indefinite loop that says while more data is exactly equal to y, okay? More data sub 0. Sub 0, that means the first character, right? You remember that from module 5, is exactly equal to lowercase y. Yeah, it is. Then get a number from the person, store it in a variable x, accumulate the value x with the sum, and then increase the count, right, by 1. That's going to keep track of how many times we're looping. And then, again, ask the user right before we're done with the loop, hey, user, you got more data? Yes or no? And then we come up here, if they enter y, right, or yes for that matter, it does the loop again. But if, like, Danny enters no, it's going to say while more data sub 0, which is n, is exactly equal to y, which it's not. And then it says, sorry, not doing this loop. And then it prints out the average of the numbers, which is going to be the accumulator sum and the count, right? The count, which counted how many times we got input from the user, right? All right. So that's just the program running. Let's talk about Sentinel Loops. Sentinel Loops. A Sentinel Loop continues to process data until reaching a special value that says stop, that signals the end. Okay, so this special value is called the Sentinel. Okay, it's just a term, right? The Sentinel must be distinguishable from the data since it's not processed as part of the data. So, hey, what do you mean by that? Well, let's take a look. Again, we're dealing with pseudocode here. So it says get the first data item from the person. While that item is not the Sentinel, right? So that thing that's going to stop this loop, while what we got from the user is not the thing that's going to signal the end, right? Process that item. And then we're going to get from the program the next data item. And if that next data item is the Sentinel, then the loop is done. If it's not, it keeps going, All right. So that's kind of what that does. So in our averaging example, the one we had before with count and sum, right? We were averaging test scores. Now, we can assume that there will be no score below 0, right? So a negative number would be the Sentinel, right? So you take quizzes, right? You don't get negative scores. So we could use a negative number, right? That would help us, what do you call it? That would help us be the Sentinel, right? Be the Sentinel. So here it is. Check it out. Again, we have the accumulator. We have the count, right? Why does he say count like that? All right, I heard you say that. So x equals float, right? We're getting input from the user. And while that number is greater than or equal to 0, yeah, that's not the Sentinel. We can do our stuff, accumulate, count, and then ask again. You got another number. If they enter a positive number, it does the loop. If they enter a negative number, this condition becomes false, and we are done. We are done. Okay? So, let's see. So this version provides the ease of use of the interactive loop without the hassle of typing Y all the time. Remember that? Yes or no? There's still a shortcoming. Using this method, we can't average a set of positive and negative numbers, right? So let's just say you needed a bunch of code to like add positive and negative numbers and take an average, because you may need to do that, right? So our Sentinel trick that we use, enter a negative number to stop the loop, right? Ain't gonna work here. So what's going on next, right? What's going on next? We could input all the information as strings. Valid input would be converted into numeric form, use a character-based Sentinel. We could use the empty string, right? If they didn't type anything, like stop the loop, right? So here is some pseudocode. So take a look at that. And I'm just going to go right to the code because I think you'll have a little easier time. So check this out. So we have a function called main. We have our accumulator and we have count, right? And notice this line right here, which gets input, enter a number, and then it says hit enter to quit, right? So the way this loop is going to work is that the person is going to enter something, right? Like a number, like 55, 23, negative 50, negative 10, right? But as soon as they just hit enter and nothing else, this whole thing is going to stop. So let's check it out. So again, we are inputting here. So when like Nyan enters a number here, right? It's going to be xstr. The variable is going to be stored as a string, even though it's a number. So while xstr is not equal to an empty string, because that's what we would do if, say, Stony hit enter, right? We're going to convert that thing that the person entered into a floating point number, store it in a variable called x, and then accumulate, and then count, and then ask the person again that they either can enter a number or just enter to quit, okay? Just enter to quit. So the key here to remember is that we're entering a string, a number as a string, and then we have to force it or cast it here to be a floating point number, all right? I know, lots of new stuff here, right? So that's that, all right? So I don't know if I'm going to be going into VS Code for at least this part of the video. Actually, I will probably. We'll see. I don't know. So file loops. File loops. The biggest disadvantage of our program at this point is that they are interactive, right? We are like working with a person, a human, right? They're sitting at a keyboard, like typing this stuff in, right? What happens if you make a typo on number 43 out of 50, right? So say some person's using your program and then a mosquito bit them and they I don't know, they slap their hand, which is on their mouse, and I don't know, they enter some bad data, right? That would really suck, right? So a better solution for large data sets, right, is to read the data from a file, right? Not having a person like type in 4,000 numbers, right? So check this out right here, and I'll probably do this one right here. Check this out. File loops. So we have a, actually, you know what? Whoops. So let me just do this. Check this out. This is going to be messy, just so you know. So pardon me right here. Check this out. Oh, no, not that. All right, copy. Okay. Let me just go into here and paste that in. All right, that's not too bad. Let me do main right here. Right. Let me save this. I'll call it demo1.py. Right. So here is my code. Okay. So I'm going to enter a file. I'm going to create a new text file here. I'm going to call it what should I call it? Data. Data.txt. And I'm going to enter a whole bunch of numbers. I don't know, 50, 100, 50, 99, 88. Okay, so I just did that. I entered some numbers in a file. I'm going to close that file. So what's going on here is we are going to, actually we're going to hard code this. We're going to say file name equals, I'm lazy, and it's going to be the same file name each time. So I think I called it data, right? Data.txt, there it is, right? So I'm going to open up this file for read access. I'm then going to set the accumulator sum to 0. I'm going to set the count to 0. And then I'm going to, files are iterable. files are iterable. I know module 5, right? So I'm going to read in a line from that file. Okay, I'm going to read in a line from that file, and then I'm going to accumulate the values from it. Now, I think this may barf. So let's run it. So it says the average of the numbers is 77.4. Wow, it didn't barf. So let's just check our file here, 77. So we have 50 plus 100 plus 50 plus 99 plus 88. And there are 5 numbers. They're divided up. I need to do this because it's going to not be happy. Divided by what? 5, right? Divided by 5, right? 77.4. And that's what our code did here. So let's step through this. So instead of having a human, right, enter this stuff over and over again, I read in one line at a time from the file. I forced that line to become a number, a float, because when you read data in from a file, it's all text. It's all text. It doesn't know that this is a number. So we force it to be a number. We increase the count, and then I just print out the accumulator divided by the count. And if I go into the data here and I just add, a lot more data, right? Even like negative 100, negative 1000, right? And I just save that and I go back and run this code. I don't need to change a thing, even though I added more data to the file, right? That's what for line in file does, right? So again, this is, whoops, did I make a mistake? No, there it is. There it is, negative 57.9, right? So this is our friend, the counted loop, right? But it's able to iterate through a sequence, and that sequence happens to be this in file here, this series, right, of stuff, right? So how would we do this, right, with our friend, right, the while loop? So let me just show you right here. Let me show you how we do this with our friend, the while loop. Okay, check this out. Okay, we're almost done with this part of the video, okay, just so you know. And I'm going to call this function here, main. I'm lazy. The file is called data.txt. It's a string. So let me run it just to prove to you that we get the same result. See, negative 57.9, that's what we got before. But now, instead of using a for loop, I'm using a while loop. So let me step through it, all right? Here we go. File name, data.txt. We're opening that file for read access, okay? We are establishing an accumulator, and I'm setting it to 0. And you know something? It should just be 0. 0.0 is a float. 0 is just, it doesn't matter, all right? And then I'm setting the count to 0 because that's going to keep track of how many times we are looping, right? And then we're going to do something called, we're going to prime. This is called the priming read. The priming read, right? And what priming read does is it reads in a line from the file. And what this while loop now, it says while that line is not equal to an empty line, an empty string, and then it does the same thing we did before. It forces the line to be a float. We accumulate it. We increase our counter by 1, the count, right? And then we're going to read another line from the file. And if there is more data, right, then this is going to evaluate true. And we're going to keep doing this until we read a line that ain't got nothing in it, right? Like there, right? So that empty line is our Sentinel, okay? We keep doing this over and over again, okay? So this is how we use a while loop to iterate through a file that we don't know the length of, right? I mean, we're not using a counted loop, right? So that's another good use of a, what do you call it? Of a Sentinel. Now, by the way, sometimes somebody may put in like the word, I don't know, ice cream, right? I'm just making this up, right? So pretend ice cream was the Sentinel, that when you reached a line that read ice cream, that's it, you're done, right? That means end of file, right? And again, it won't say ice cream, but I'm just trying to humor myself, right? So instead of equaling a blank, we would say ice cream. So when that line, as long as that line is not equal to ice cream, read it in, convert it, accumulate it, count, increase the count, and then read another line. So check this out. If I run this, right, boom, same result, right? So there you go. That's what a Sentinel does. It signals to your code that that's the end, right? Sometimes you would see something like, I don't know, like that, or I don't know, whatever. You just see something, either an empty line or a code word or something like that. All right. So that's that. All right. So let's go back here. Let's go back here. Play slideshow. File loops. All right. Good. Nested loops. In the last chapter, we saw how we could nest if statements. Again, this is module 8. We did module 7 like a few weeks ago, right? So you saw how you can nest, right? If statements. We can also nest loops. So just so you know, I'm going to go back. Where is it? Where is it? Let me just see. Hold on one second. Right here. All right. So check this out. And again, I think sometimes code is a little bit, whoops, that was the end of section 1. We're almost done here. So let me just go through this code and talk to you about nested loops as they apply right here. So check this out. I'm going to go back here. No, okay. So again, we're going to hard code this to data.txt because I'm lazy. Data.txt, right? We're going to open that file for read. We're going to set our accumulator. We're going to read a line in from that file. And check this out. Now, what this is doing here, right, it says update sum and count for values in a line. So what's going on here? What's going on here? Why is there a for loop inside of here, iterating through and splitting stuff on a comma? Okay, so let's look at our data file. And this is, again, a very common thing you'll see in business. I'll enter 25, 20, 33. I'm going to cut this down, by the way, just to show you here, all right? We'll do 3 lines. So pretend each line had just random, I don't know, bits of data. I don't know what it's for. It's just a bunch of data, right? And notice how each line I'm putting like different numbers of like, I don't know, this one has 5 numbers, this one has 1, 2, 3, 4, 5, we'll add another one here, right? And this one has 4, right? So how would you deal with something like this? You were asked to write Python code to read this data in, right? And add all that stuff up, right? So what this is doing here is using that loop that we used before, using the Sentinel of nothing, which would be like right down here on line 4, that's nothing, right? Empty string. However, when we read a line in now, we're going to split that line, right? And this is going to create here a list, just so you know. And then we're going to iterate through each string in that list. Because remember, when we read stuff from a file, it's a string. And we're going to force it to be a float. We're going to accumulate it. And then we're going to increment our counter, and then we're going to read in the next line. Okay, so let me show you this because this is really cool. Again, get this concept in your mind that you may have not just a single number on each line, but you may be given different lines, right, in a file separated by commas in this case, right? This is called comma-separated value format, by the way. You may see it in Excel if you've used it before. But this will handle it. Let's say, don't make a fool out of me, code. So guess what? I think I have to call the main function down here. Yeah. Let me push play. So there it is. There is that big number. And I'm not going to go through and add them all together. But maybe I should, because that doesn't look right, does it? Does it? Does it? So let's just check this out here. So split, sum, count, line. Oh, so what it's doing is it's printing out the average. So they wanted me to do it like this. They wanted me to actually, hold on one second. So I'm reading in a line, right? Oh, you know something? oh, let me do this. Print the average of the numbers is, let me try this. Let me indent that one line. So it did it each line. You see this right here? It did 32. Let's go check that out. No, say something's wrong, okay? It's because we're getting near the end, right? And that's where my stuff is breaking. So let me just see what it's doing here. Count. And then I wanted to, oh, it's the average. That's why. That's why. So if I just do the sum here, just to show you this, right? Let me just show you this. And there goes my dog because it's time to eat, right? So there is the sum, sorry, okay? So that's the sum of each line, okay? So, yeah, sorry about that. So this is the use of nested loops where I have, I'm sorry about the dog, by the way, I have an outer while loop reading through each line of the file, and then I'm having a loop inside reading that line, splitting it on the comma, which is the comma that's separating each of the values. And by the way, it could be a pipe. You see this thing right here? It could be a pipe, could be a pipe, could be a pipe here, could be a pipe, could be a pipe, could be a pipe. Sorry about the dog. Pipe, right? And I'll change this in the code to be a pipe, right? And I'll run it, and you'll see we get the same results. So it's just splitting using that pipe instead of the comma. All right, so that's part one for module 8 of this little video. We'll be back to talk about computing with Booleans in the next video.